Point 0. Permutations in organized counting. Enumeration is a counting technique in which each possible outcome is listed one by one. And a permutation is an arrangement of items in a definite order. In this example, we'll see both. How many permutations are there of the letters in the word cat? So pause the video to rearrange the letters of the word cat in as many ways as you can. So you should have ended up with 6 unique ways of writing this. This is unique because the order in which these are written matters. That makes it a permutation because we're counting how many different ways this can be written. Next, this is enumeration because we're listing each of these different items. And you can imagine that this enumeration method becomes much more challenging when the number of letters are used. So we'll be learning those techniques in the future. Next, those techniques that I was discussing are organized counting techniques. So, the total number of possibilities that can be determined without listing each outcome individually. So here's an example. Counting using a table of values. How many unique rectangles can be drawn using the grid provided? You can pause the video to try to answer this on your own. But here's a technique that can be applied to this. Think of the ways in which you could place these items on this grid. So if I had a 1 by 1 rectangle, I could use this position, next position, and there's a total of 4 rectangles that are possible under those dimensions. Next, a 1 by 2, I could have this pair, or this pair. That's 3. And a 1 by 3, remember that's rows and columns. 1 by 3 looks like this shape here, and that makes 2. And a 1 by 4, that's using just the outside border. And that is each of the different outcomes that are possible. We can take the total of this by adding, and we end up with 10. Maybe you want to pause before attempting this next question. If we were to look at the following. This is identical to the previous problem. And in mathematics in general, what we do is sometimes look at the smallest case possible and try to make extensions of that concept. So if we already looked at this problem here and we knew that there were 10 total, well, that's the same as for the top row, there will be 10 rectangles. On the bottom row, 10 rectangles are possible. And then if we were to have 2 rows included at the same time, the same number of rectangles would be possible. So there's 10 for this as well. So I'm just showing that if it was 1 by 2, like this right here, it could still have 4 for that way. If it had this shape, there'd be the same amount. So this becomes 10 rectangles. Altogether, we end up with 30. So a table of values can help you organize your counting so you don't miss or overcount any of the possible outcomes. Lastly, how many different outcomes are possible if a coin is flipped 3 times? So try to answer this question without any supports, an opportunity to pause, and now we can begin looking at a tree diagram. A tree diagram can help illustrate this problem because it has the solution expressed as a sequence of events, which we call compound events. It's an event made up of other events. The event overall is the sequence of 3 outcomes. And we can break that down into the first coin flip of it's either heads or tails. And for each outcome, as we go down the branch of the tree diagram, it is either heads or tails. And from each outcome, heads or tails. So if we trace each path, heads, 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 this is the outcome of heads, heads, heads. And similarly, let's just trace a random path. Tails, heads, tails. So altogether, there are 1, 2, 3, 4, 5, 6, 7, 8 different outcomes in this experiment. So a tree diagram illustrates these compound events. The problem can be modeled as a sequence of independent choices, and each path represents a unique outcome. Good luck with the homework.